Okay, so recording of the event has also started. Welcome to the May 2025 session of the BA course. I'm Dr. Malolan. You can call me, I'll go by the handle Milo. You can tag me in your discourse posts in case if you have any doubts. So this is going to be the first session of the course. So before we start, for all those who have joined, what do you think this course is about? Since you have seen week 1 and hopefully week 2, what do you think the focus of this course is? What is your perspective? Yeah, go ahead, Rohit.
Sir, in BDM, we focused more on data and collection of data and analysis part. Here we are focusing more on interpretation of results and visualization of data. I mean,
Okay, that
how to present it in a better way so that the main information is being uh, correctly captured by the viewers or those who are getting the information.
okay, fair enough. That is week 1, but I have 11 more weeks to go now. So what do you think the rest of the course would be?
Sir, maybe just to apply these statistical techniques onto the real business and get the insight from that.
Okay, wonderful. So apply the statistical techniques, whether be prescriptive or descriptive or predictive, on a data set for the business. Super. So I'm anyhow going to look at statistics. Why do I need this course called Business Analytics 10? You're absolutely right. That is what we are going to be doing. But why do I have to have a course for it? Statistics itself would solve the problem, no? Because that is what we are going to do.
So
Ah.
statistics is there, but we have to customize it according to the business needs as well.
Wonderful. So exactly what you guys have been selling. So business analytics. Yeah. So the BA course sits in between two things. You have the stats on one end and you have the industry on the other. So the bridge between these two is going to be your BA, right? So why do you need this bridge? Is the first question. You need this bridge because here you have techniques. These techniques cannot be directly used in the industry. You will have these techniques, you will have data, you will have data, you will have these techniques. Both of this go into the BA where you will see how to modify the data so that a particular technique can be used. Once it comes out, then you take the business problem from the industry, merge it with this, and you give a solution. So BA is going to be acting like that bridge. It's going to take the business problem, the data for that business problem, compare it with appropriate statistical techniques, see which technique would be best suited. For that technique, what you should do on the data. Then after doing all of this, if you build the model, if you get the result, how do you interpret the result? How do you propose a solution from that result? So this is what your entire 11 weeks or 12 weeks of content is going to focus on, right? So that is going to be the BA course. Okay. Right. So people, please try to join with your uh, uh, IIT Madras email ID, your study.iitm.ac.in. Because if you keep on coming in, I will have to break my flow and keep admitting you. So a gentle request from my end. So kindly use your BS course email IDs. Okay. So this is the course, right? So if this is the course, you should first understand what are the requirements for this course, right? To get a course grade, right? to get a course grade, apart from your regular requirement of passing, you also have to have an end-term score of how much? Anyone? How much should be the end-term score?
So 40, 45 it is.
Oh, you want to get 40 out of 40, yeah? End-term score is out of 40. What is the eligibility to get a course grade?
7, sir.
No, that is for a different thing.
10 out of 40.
It is 10 out of 40, right? 25%. So in your end term, you must score at least 10 out of 40 to get a course grade. For you to be eligible for LNUM, for you to be eligible for the end term, what are your requirements? There are two. What are they?
So we have to score at least 7 in one of the quizzes.
Not in
And
one of the quizzes.
in both the quizzes.
Both put together, the aggregate quiz score. Your quiz score is going to be max of quiz 1, quiz 2 into 0.7 plus min of quiz 1, quiz 2 into 0.3. This score, this quiz score, this joint quiz score must be greater than 7 out of 7 out of 20. That is your requirement at 35%. That is requirement number 1. What is requirement number 2?
And we have to submit one of the 3 assignments.
One of the first 2 assignments.
One of the first 2 assignments. Sorry, sir.
Submit at least one of assignment 1 or assignment 2. So you must meet both these requirements. It's an and criteria, all right? So you must submit at least one of the first 2 assignments. You must get a course score of a quiz score of aggregate quiz score of at least 7 to be eligible for the end term. And in the end term, you must get at least 10 out of 40, right? So these are your requirements for getting a course grade in this course and for you to pass the course. So please make sure that you meet it. You should make sure that you meet it, right? Okay. So having said this, now let's come back to this guy. So your BA course is going to be a bridge between your statistics and industry, where you are going to have techniques, statistical techniques. You must know how to modify that particular data, how to modify the data for that particular technique. When I say modify the data, you will not be changing the data, but you will be transforming the data to a requirement and then using a particular statistical technique. Having said that, week 1 was what? Week 1 focused on what? Week 1 of the course, which was already released.
So different types of representations, like graphical representations.
So it was all about visuals, right?
So data visualization.
Exactly. So what type of graphs you can use for what type of meaning that you want to convey. So we actually started off with this guy. We told you, once you have done all the analysis, if you want to show the solution to someone else, what type of graphs are available for you to show that particular insight. So that was week 1, right? Why this was the first week instead of the last week is because we want you to start looking at everything that comes henceforth in terms of the visuals that we will be doing. right? Most of the time it will be tables, and whenever we show you a table, you should know, oh, this is the reason why they are using a table, right? So for that purpose, we started off with the solution. A second reason why we started off with the solution is most of you, having gone through a lot of rigor in statistics, would be very good in the math part. But the ultimate user of the solutions that you propose will not know the math behind it. He will only want to understand the output. That is why, to emphasize that, our week 1 was about visuals, right? So always remember, the visual that you choose for presenting your solution is very, very important. And why do we use visuals? Because a picture can tell you 1,000 different things that words may not be able to convey in a short span of time. That is the reason. Okay, so that was basically week 1 visuals. I will not be diving much more deep into this, but any doubts in week 1 from you guys? Because I want to focus on week 2. But week 1, do you guys have any questions, any clarifications that are required?
Oh, sir, it's clear, sir. TA session has been done. So,
All right. Yes, Neha.
So my question is, some of the data were given to us. Like, where can I find those to work on my own project?
You want to have access to those data of
Yes,
week 1.
like they were telling us that we are giving you this data and you can work along with us, but I'm not able to find them. Like
In
for visualization and everything, they were doing it, and we were supposed to work with them. But
for the TA session, no?
yes,
In the TA session or in the video
no,
lecture?
no,
In the
no, the video lectures, sir.
video lectures they have. Okay, I will check it out. We have it will be there. All the data that you require will be there in the supplementary content. Let me see if I have access and I can open and show
Uh,
you.
so
Okay,
I
maybe.
So I searched there also, but they only have the live sessions and all that. We don't have any data in the supplementary content.
Really,
For
because today afternoon I was checking it out and it was there. A lot of people are raising concerns about access issue. No, wait, 1 second. One second, let me show it to you so that it gets closed. Okay. This is the back end, so it looked like this.
Sir, somewhere I saw while you were scrolling up and down the PYQ of quiz one PYQ and all. So we do not
No.
have the access to.
No, that and all you will get later. This is a back-end access where we have uploaded and kept. They will all be released at the point of time, not right now.
No,
Your
I
PYQ.
mean, so you mean to say 13th July is our quiz one, right? Before that, we will get the previous.
Yeah. Once the 4 weeks are over, you will get access to the mock. Previous year question papers, you have a separate drive for it, where you will have access.
So you have that. Can you please share with us?
Can you go, if you go to the discourse, once you go to the discourse, what is that TA session? Once again, resource hub. You go to this resource hub kind of thing, TA sessions, queries, recordings, and resource hub, May 2025 term. Here you will get all your links being posted. The TAs will post all the links here. Before the exam, what are the corrections that were made for the quizzes, everything will get populated in this thing. So you can just track this.
I'm
Okay.
just looking for the PYQ, sir, and I have searched.
Exactly. That's it will be given to you once the 4th week content is completed, because your quiz 1 syllabus is week 1 to 4. So 1 to 4, when it gets over, you will get the this thing. You'll get all the PYQ, everything in that. Okay. Right. You see, in supplementary contents, you will have something known as data and codes. So if you go there, data and codes, you will have a drive link. In that drive link, you can find it. Okay, Ma? Are you able to see my screen?
Yes, sir. Now, after refreshing, I can access them.
Yeah. So just check it out.
Yes, sir.
When will you be releasing assignment 1?
Assignment 1 will be released week 5.
Week 5. So it's after the quiz.
No. Before the quiz, closing after the quiz. Because 5 weeks of content will be released before quiz 1. The closing date for assignment will be after quiz 1.
Will it clash with the quiz 1 preparation time?
Yes, it will. It will be 1 week after the quiz 1. So if, let's say, quiz 1 is on the one Saturday, one Sunday, the next Sunday will be the close date.
If it is going to be 18th July, it is okay.
It will be like that only. Okay. So any other questions from week 1? Week 1 should be fairly easy, but anyhow. Okay. So let's go to week 2. Now this is where we actually start to see this link between the business problem and the techniques that are there. Right? So can someone tell me what is the concept that is discussed in week 2? What is the broad statistical concept that is being discussed?
We are trying to fit the data into some distribution, some known distribution.
Super. So it is distribution fitting. So that is the topic. Now, if there are someone with experience, why is it important for me to know what type of distribution the data is coming from? The topic is that.
So we can ignore tail or the tail end data or irrelevant data and concentrate on the part which gives most bang for the buck.
Okay, fair enough. So I can identify my tails, basically my outliers if they are required, and I can remove them out. Super. That is one reason. Anything else? Anything else?
So the past trends can make us help us make future.
I can choose an appropriate model.
Why?
I can choose an appropriate model to represent the data.
What model? Can you give me an example?
Probabilistic model. Whether it was a normal distribution or a multimodal.
Okay. Why would that help you in modeling? Can you give me a very basic example?
If I can't model it, I won't be able to analyze it.
Okay.
If I got a large number of data, if I know that it is probably following a binomial,
okay,
I can look for binomial parameters. I can estimate the parameter and then check the validity.
Okay.
So that once I have a model, then I know that how the behavior is.
That is only, you're not doing a model, you're only finding the distribution and its parameters. So when will it help you in modeling? Model is something different. This is something different. What you're telling me is, I'm trying to identify the parameters of the distribution. I'm trying to find out the distribution.
That's
fair enough. It's going to help you in the modeling. How? What is a model? Can you give me a basic example? Very basic example that all of you would have studied.
Can you be more specific? I'm not clear of your question.
My question is, can you tell me some modeling techniques that you have learned, the fundamental model that you have studied so far? You're in a business analytics course. So in your statistics course or in your machine learning course, what is the first basic type of model that is taught to you?
Linear regression.
Wonderful. You have got regression. What is the assumption of regression?
There is a correlation. There is a correlation to the output from some of the identified inputs.
Okay, wonderful. That's a correlation between, there's a relationship between the output and
either it is a linear or could be multi.
Correct, whatever. So it's regression means association. So there's an association. Super. Once you have fit a model, how do you know that the model is the best model?
Sir, we have to test it in training. We have to train the model and then we have to test it.
Okay, you test a model, you get an R-squared value. We will look at all of these later on. But since you have studied statistics, I want you to find out a particular term. When you are fitting a model, what is that you try to look for in a regression model?
Goodness of fit.
Okay, goodness of fit means what? Tell me even more basic term. Tell me in even more basic terms.
Error.
Super, error. Estimation of error. Super. How should the error be when you fit a regression model?
Minimum. We always
you want the
minimum zero.
You want the value to be minimum. Super. That is a value. But when you fit a regression model for, let's say, 10 data points, the values of those errors will be 10 different numbers. So how should that errors be distributed?
They should be like as close as possible to the...
No, that is minimum, but there should be a distribution for that error, no? What should be the distribution of the error?
In normal, it would be a normal distribution.
Not in normal. Wherever it is, for whatever data you fit, the final errors that you get from the model must be normally distributed. Right? Yeah. So now you see the link. We are doing distribution fitting because once you finally fit a model, the residuals, the errors of the model are expected to be normally distributed. So you must do a check there. So can I use distribution fitting to check whether those errors are normally distributed or not? Or are they Poisson distributed? Or are they normal distributed? So on and so forth. So for that purpose, you need to know how to check the fit of a particular distribution to a data set. That is reason number one, why you need to study distribution fitting for use in the industry. Everyone with me so far? Yes, no?
Yes.
Okay.
So sorry. Yeah. So it should be normally distributed irrespective of it is left skewed or right skewed. At the end of the day, it should.
No. We are talking about the errors from the model. Okay. So when you fit a model, the errors must be normally distributed. They will be called something known as IID. Maybe future you will learn all of this. They will be called independent and identically distributed with a mean of 0 and a standard deviation of 1. That is the ideal errors. The ideal error would be IID with a mean 0, standard 1, standard deviation 1. Normal, mean 0, standard deviation 1, and they will be independent and identically distributed. That is for the error characteristic that you expect. Okay.
So we are expecting the pattern to fit. I'm not getting the distribution in what terms you are telling us. Like the normal distributed.
Let's say you fit a model, you get errors E1, E2, E3, so on up to let's say 500. 500 data points you have fit. You have got this thing of 500. Let's not even take such a big thing. Let's take it small. Let's say you have fit 30 data points and you have E30. So what you have 30 different error values. What is the distribution of these error values? They should be normally distributed. Right? So how do you check whether they are normally distributed? One check is to do a distribution fitting to see whether they are actually normal with a particular mean with a particular standard deviation. Okay?
For some strange region, if it is not normal, what does it signify?
Usually when the errors are not normal, it basically signifies that you can build a better model.
How close it is coming to normal is what we can check. But if it is not normal, what does it signify? Anything to do with the data that we collected, or?
No, it does not. Look, you never question the data. You say this model is not the best model. You can find a better model.
Okay. Our fitting was not correct. That's what.
Yeah. So more than normal distribution, what you actually look for is IID, whether the errors become independently and identically distributed. If they are not independent, then there are some dependence that you can capture, and hence the model must be changed.
Okay.
Right? So that is what you go. But once you reach that state, automatically this will fit. Around 90-95% it will fit. Okay.
Can
so that
we
is one,
explain this in a visual term?
Visual term, not. What is the shape of a normal distribution?
Yeah, it's a bell shape.
It's a bell-shaped curve, right? So it's going to be sitting like this. So what you try to do is, let's say it's a bell-shaped curve, then errors must be, the value of the errors must be all of these values, right?
Yes.
So only if they sit there, it's in that bell shape. Let's say they don't sit like this. Instead of this, it is something like this. These are the values. Then what will happen? This is not a normal. Or let's say it is something like this. It's going like this. This is also not a normal. Right? So that is what we are trying to see. Whether these errors are going to be normally distributed or not.
So in this cases, we normalize the data, or?
No, this has nothing to do with data. Remember, Ma, we are not looking at normalizing the data. We are looking at the end result errors.
Okay, sir.
Right? You fit a model, you predict a value, you take a difference between the actual and the predicted. So E1 is basically going to be Y actual minus Y predicted. Right? This value, the differenced value must be normally distributed, which means 50%, or let's say the mean is 0, which means this side, whatever number of values you get, approximately the same number of values will be sitting on the other side. The mean is at 0. For example, it could be any number, but it's usually at 0 is what you ideally want. Fine?
Okay, sir. Yeah.
That is what we finally do. But for doing that, you need a distribution fitting. Okay. So this is one reason. A second reason why distribution fitting is very important is when we do research, right, we will not get a large volume of data. What we will have will be a small value of data. For that small value of data, we try to see what distribution best represents that data. Once we get a distribution for the data, we can then use that to simulate more values, right? And do further research, further explorations, let's say further testing, so on and so forth. So for that purpose also, we need to know distribution fitting, for which you will say that this random variable follows this type of distribution, and hence I am going to use a similar type of distribution to generate more values, which I can use for testing purposes. Making sense? So that is why this particular topic, which is going to be distribution fitting, is going to be a very, very important topic for you. All of you clear with me so far?
Yes, sir.
Okay. Sir, one more time in the summary, sir, please.
The summary in the sense?
Very briefly, I mean, if you can sum up, why do we need this?
Okay. Distribution fitting is very important for two reasons. One, when you are fitting models, you might have certain assumptions that you will have to validate. For validating those assumptions, you need distribution fitting. So that is number one. Reason number one. Reason number two is when you are given a small amount of data, if you can identify the parent population distribution from which it comes, then once you have done a distribution fitting, you can identify that parent distribution, and hence you can use it for further simulating data that you can use for testing purposes and generating more data for whatever reasons that you may require. So that is the second reason why distribution fitting is very important. In real world, sometimes you might not have large volume of data. So in that case, you will need to simulate the data, and simulation data must follow the same original distribution from which the sample had come. So for that reason, you need to know distribution fitting. Okay.
So when you're talking about the validation part, like we are making some hypothesis and then we are after fitting it, we are proofing that if it is true
No,
or false.
no. All you have to know is, let's say currently you are given a trained data set, a test data set, correct?
Yes.
Whenever you are fitting a model, let's say so far in the topics that you have learned, wherever you are fitting a model, you are directly given a trained data set and a test data set, correct?
Yes, sir.
Okay. But in real world, let's say you don't have sufficient data to to train and test. Let's say you only have 30 data points or 40 data points. Using 40 data points, you will have to fit a model. And
Yes.
you will also have to validate that model. Then it becomes very difficult. So what you will do for those 40 data points, what is the distribution that it follows? I will identify that. So once I've identified that distribution, I can generate 400 data points from that distribution. I can do data generation. Once I've generated that data, now I have 40 plus 400. On the 400 data points, I will train. This 40 data points, which were my original data set, I will use it for testing. Making sense?
Yes, sir. But wouldn't it be a manipulation? If we had more data, then it can be some other distribution also, right?
No. That is the entire topic. I've not yet gone into the topic. The topic is what distribution is fitting the sample. What we will be saying is this sample comes from this population or not is what we will check, which is what I will tell you later. So when you check that population and identify the population, from that you can start pulling out. For example, let's say I have 10 human beings. Okay. I look at those 10 human beings and identify that those 10 human beings are from, let's say, Tamil Nadu. I do some tests, I identify, okay, they are from Tamil Nadu. Now I am developing a product for people of Tamil Nadu. What will I do? With 10 people, I can't do. So I will simulate more human beings who are similar to Tamil Nadu, who are similar to characteristics of Tamil Nadu, and use them for developing my product. I will develop that product and then test it on these 10 who are actually from Tamil Nadu. Right?
Okay, sir.
The aim is whenever you have data scarcity, to generate more similar data points, you can do that only from the parent distribution. So for identifying what parent distribution I get it from, I need distribution fitting.
Got, sir.
Right?
So, one question. I mean, we have some textbooks in maths and stats. Would there be some reading material, some textbook kind of a thing?
The explanations that I am giving are from experience, right? They will not be there in textbooks per se.
No, sir,
They will
we
not
forget, right? That's why I'm asking.
I totally agree. The technique will be there in the textbook. But the reason why you do the technique like I'm explaining right now, that comes from the use of the technique in several places, discussion with faculties, so on and so forth. So that will not be there in a textbook, but the technique that you are being taught, that will be there in your textbook.
Okay.
Okay.
See, I think very well said, sir. See, for example, the drones and all in Operation Sindoor, they can't go to war every time. So they will have a set of data, and then whether it's a bird or a drone, they will try to feed it. and then create that distribution. According to the distribution, parent distribution, they will do that. Right?
Exactly.
You have articulated. Thank you.
Okay. So having said this, this is the reason why you are studying week 2. Okay, distribution fitting comes. Okay, now tell me, what is the technique that is being discussed here? What is the statistical technique? You have studied the statistical technique also in stats, by the way. So what is the name
Goodness
of
fit.
Excellent. What goodness fit?
The chi-square.
Exactly. So it is known as the chi-square goodness of fit. I'll be referring to this as GOF, the chi-square GOF, right? Chi-square goodness of fit test is the fundamental test that is used for identifying the parent population distribution. Okay, super. Now, what is required for a chi-square goodness of fit test? If you have seen the videos, can you tell me? What is required? If I want to do this chi-square goodness of fit test, what is the table that is required? Let me ask you like that.
We need bins and the observed frequency according to that bins.
That is, those are the columns. What is the name of the table?
Frequency
It
table.
is known as a frequency table.
Frequency table, right? And degree of freedom also is required.
You need the frequency table. So for performing a chi-square goodness of fit test, you need a frequency table. And someone already told me a frequency table is a table that has 3 columns. Column number 1 is going to be your bin. Column number 2 is going to be your observed frequency. And column number 3 is what? Expected frequency. Wonderful. So these are your 3 columns for the table. Super. Let's come to it again. Let's say you have this table. Okay. What is the test that you are performing? When I say test, you must tell me what is the null hypothesis, what is the alternative hypothesis, what is the test statistic, and what is the, let's say, comparison. Let me put it like that in very simple terms, or not even comparison. Let's say what is the check that you do and what is the conclusion that you will derive. All of these will be there whenever you are performing a hypothesis test. This is a hypothesis test. So what is the null hypothesis for this particular test?
That there is no difference between observed frequencies and expected frequencies.
Which means what?
Means that
Means both the distributions are same.
Both the distributions are same? No.
Yeah.
Can you tell it to me in a different way? You're right, in a sense that your understanding is right, but I want the actual articulation, because hypotheses are very articulative. So what is the null hypothesis?
The objective frequency or the expected frequency data is coming from the same distribution.
Wonderful. More precise would be the sample.
Whether it is an exponential distribution or whether the distribution is exponential or it is a uniform distribution.
No, that is when you go specific. When you specifically go, you can say the distribution, but in general, the sample follows the claimed population distribution. This is your null hypothesis. The sample which gives you the observed frequency follows the claimed population distribution. You claim that this sample is following a normal distribution with a mean of 100 and a standard deviation of 25. You make that claim. Then the null hypothesis is the sample follows the normal distribution with a mean of 100 and a standard deviation of 25. That is the null. The status quo, the claim, is always the null hypothesis in this case. I will tell you why in a minute. The alternative is that it does not follow. The sample does not follow the claimed population distribution. That is the alternative. So all of you clear? So whatever claim I make, my vehicle is giving me a mileage which is normally distributed between with a mean of 25 and a variance of 5. That is my null hypothesis. The alternative is that no, my vehicle is not giving a mileage with a mean of 25 and a standard deviation and a variance of 5. That is going to be my alternative. So the claim that is being made is always the status quo in this case. Fine? Yes, no?
Yes, sir.
What is the test statistic? What is the name of the test?
Chi-square test.
Exactly. So it is a test statistic is going to be a chi-square test statistic. So the name of hypothesis tests are usually an indication of the test statistic. So when you do a test of means, the test statistic is a Z. So it is known as a Z test or a T test, right? So here the test statistic is a chi-squared. How do you compute it? What is the formula?
It's the square of the difference of the observed frequency and expected frequency, and
Okay.
then dividing by the expected frequency and then summing it up
Summing it up over what?
to all the bin values.
Exactly. So I is equal to 1 to k observed minus expected the whole squared by observed minus expected the whole squared by expected summed up for all the k, where k equal to number of bins in the frequency table. So here I'm going to have bins 1, 2, so on and so forth. Up to k. So your frequency table's first column is going to give you an indication of the number of summations that you'll have to do. Okay, so that is your test statistic. Super. So you have got a computed value. What is the check that you do? What is the check that you do?
We are checking the points of observed and expected points if they are matching or not.
That is going to be computed by the test statistic. So what do you do? What do you check? What do you check?
If the difference is significant via the p-value.
Okay, the p-value is the final result. Okay, fantastic. How do you know something is significant or not?
So that depends on our confidence, like usually 0.05.
Exactly. So what I want to check is whether this chi-squared computed, what are we checking? Remember, we are checking the difference, squared difference. So OI minus EI the whole squared by EI. Okay, since you have studied statistics, what does this guy look like? Leave out the square. Without the square, if I just look at this term, OI minus EI by EI is analogous to something. It's different, but it's very similar to some term. What is that some term?
So it's Z similar to Z score?
No, Z score is what? Z score is X bar minus mu by sigma. That is completely different, huh?
Yeah, like it.
That is mean, that is where, then you have standard deviation. Here, OI minus EI is what?
Say error.
It's a type of an error, super. So it's the error. What is EI in the bottom? The analogous to if I error by something. What measure is that? Error by something. Let's say I put error by actual, for example. When I take error by actual, what is that measure called as? I'm taking the difference between the two and dividing it by the original number.
Is it the p value?
No. Think very, very simple. If I do this, error squared by n, what is this? I'm taking the summation of all errors, squaring them and dividing by n. Squaring every error and dividing by n. What is that?
Squared mean error. SME.
This is the mean squared error, MSE, correct? The mean of squared errors is this thing. Similarly, I am taking the summation of error at a point by actual at a point. What is this?
Standard deviation or variance?
No. Standard deviation of variance is yi minus y bar.
Mean deviation.
What is that? Mean?
Mean deviation.
Mean? No. Mean. If I give you this flow, now I put two bars around that error.
Mean square distance.
Absolute.
Mean square distance.
Mean absolute
error.
That's all, huh? Okay, I have to give you this also then. This is almost similar to what? This is equal to what now? Mean absolute percentage error. None of you have heard of MAP. MAPE. Mean absolute percentage error. So all of you focus on MSC, but MAPE is also there. Now look at this guy. OI minus EI the whole squared by EI is doing what? You are, instead of putting the mod, you are taking a square so that it's a positive number. OI minus EI can be a positive or a negative number. EI or OI, both of them individually are always positive numbers because they are frequencies. They cannot have a negative number. They should be 0 or something positive. So now you are taking the square of something, dividing it by the expected value, right? The expected value is nothing but your actual value that you expect that should come. So what is this? This is basically a relative measure. It is measuring how far away something is from the expected value, and you are summing that up. So the chi-squared measure is nothing but a squared absolute deviation value, right? So if you are going to check if this chi-squared is too big, right? And if it is too big, chi-squared, if it is too big, you will make a conclusion. What would be the conclusion? If the chi-squared computed is too big.
Reject.
If it is too big, your conclusion would be reject what?
HO.
Reject H0. Super. So when the chi-squared value, when the deviation, the squared absolute deviation of all the terms in your frequency table is very big, you will say, okay, the observed value is too far away from my expected value. Hence, I must reject my null hypothesis, and therefore I will conclude that the sample does not follow the proposed population parameter, population distribution, right? So that is going to be the conclusion. Now comes what you were telling. X chi-squared computed is too big. So the question is, how big must it be, right? For someone, it could be even, let's say 10, a value of 10 could be big. For me, I'm a risk taker. It could be 30. So the question is, how big must it be? For that, you need a reference value, which is known as the chi-squared tabulated. And this chi-squared tabulated is got for a degrees of freedom and at a specified level of significance alpha. So when chi-squared computed is larger than chi-squared DOF at an alpha, you will reject H0. Or when p-value is dash, you will reject, is dash, you will reject H0. What, fill in the blanks? What is dash?
Greater than 0?
Greater than 0, you will reject H0 or no? P-value will always be greater than 0. Getting a
less
0
than
value is very...
significance level.
Said 0.95 was
less than 0.95. No, someone was telling is less than
Significance level.
is less than alpha significance level, you will reject H0. Right? Why is this? What is the definition of p-value? Can someone define p-value? I've been asking this for the past 2-3 terms. No one has been able to tell me what is meant by p-value. Give me a proper definition.
Sir,
Huh?
Sir, it generally refers to
it's the
I'm not-
probability that this value could have occurred by chance, something like that.
Not by chance, you're almost right. It is a conditional probability of observing the sample given H0 is true. So p-value is nothing but the probability of observing the sample given that the null hypothesis is true, right? So that is the definition of a p-value. So when you get a very small p-value, what does it mean? The probability of observing this sample which is in my hand, given that H0 is true, is very low. Which means what? The only thing that that would lead to such a low value is the H0 being not true, because that is the assumption. The sample is actually in hand. So probability of observing the sample given H0 is true. When it is very less, you will reject H0. How small should it be? It should be less than alpha, which is your risk-taking appetite, which is your 5%, usually 5%. So that is the reason for it. Okay, all of you with me so far? Yes, no?
Yes, sir.
Wonderful. So The thing that I have described till now over the last 45 minutes is only the statistical piece, only the technique. We have not yet come to the BA piece. Since we have run out of time, I cannot do it in 4 minutes. What I will do is, I will do the BA piece next week, and I'll give you a precursor of what that will be. Till now, in your statistics course, you have always been given a frequency table and asked to do all of these computations and give a result. That is what you have been trained to do so far, which is statistics. But in the business world, you will not be given a frequency table. You will have to construct the frequency table given a sample, which is what the BA course will do. In our next class, I will be talking to you about how to construct this frequency table given a list of, let's say, given a set of sample data points that are there. So given, let's say, sample data points of 100 data points, how do you construct this frequency table? That will be what we discuss in next week's lecture, next week's live session. Okay? Any doubts so far?
Sir, one
Yes.
thing.
Okay. Yes, Lokesh.
Sir, how is that chi-square tabulated is calculated?
Chi-square tabulated is got from the table. They are standard tables.
Okay.
One second. Let me try to open a table for you and show you. Just give me 1 minute.
Yes, sure, sir.
Okay. So this is a Z. Yes. Chi-square. Right? So this is how a chi-square distribution will look like. The shaded region is your rejection region. So what I will do is I will go to this table, find the degrees of freedom, the gamma or mu that you want to call, that is going to be your degrees of freedom. Let's say we take 4 degrees of freedom, for example. So for 4 degrees of freedom, at an alpha value of 0.05, 5%, the value is 9.41. So you'll take 9.41 and you will compare it with your chi-squared computed. If your chi-squared computed is less than 9.41, you will say do not reject H0. When it is greater than 9.41, you will say, 9.49, you will say reject H0. Right? Always remember, your statements, your conclusions are always on H0. They are not on HA. The conclusion is always reject H0 or do not reject H0. You never say accept H0, accept the alternative, do not accept the alternative. All of these are wrong. The correct statements are reject H0, do not reject H0. That is the conclusion. Fine?
Yes, sir. Yeah, got it.
And again, since I'm showing you the table, if you look at this curve, the minimum value is 0 because it cannot be a negative number, because a square divided by EI, it always becomes a positive number. So it's always going to be 0 or something else. The ideal value is 0, an exact match between observed and expected value. As the observed and expected value difference increases, the chi-square tends to move away from 0. So what you're trying to say is, given a risk appetite of 5%, where should be my cutoff? So that beyond this I will reject, below this I will not reject. That is the test. Okay?
Got it, sir. So as the alpha value increases, the tabulated value of chi-square will increase. Is that
Yes, obviously, no. Yeah. Obviously, no, because you are going to be pushing this region down, which means from 0 you'll move further away. Either when your alpha value increases or when your degrees of freedom increases. So when the degrees of freedom increases also, you look at it, it goes up.
Got it. Yeah.
The shape of the curve changes. Okay. Yes, Neha, you had raised your hand. Go ahead, please.
So, how the taking appetite changes? Like, is it always 5% or it will change according to the data?
It will change. It will change. It depends on something known as the type 1 error, type 2 error. Have you guys heard of it?
Yes, yes, sir.
So your type 1 error is alpha. So how much of a type 1 error you are willing to take matters in your this thing. So more type 1 error means lower alpha, higher alpha, sorry. Less type 1 error means lower alpha. So that is what drives the thing. Okay.
So, what is the meaning of x squared DOF comma alpha? Like, we are also taking into consideration the DOF part and risk taking part. So, what?
Correct. If you look at a chi-square distribution, the shape of the distribution gets affected by the degrees of freedom and your alpha. As I was pointing out, one second. So this curve's shape, right? It changes as your DOF increases. It will become more skewed. So in those cases, as your degrees of freedom increases, your chi-squared value goes up. As your alpha decreases, your chi-squared value goes up. Right? Yes.
Okay.
No?
Okay. So it is directly proportional to
Degrees of freedom and inversely proportional to alpha.
Okay. So one more question, like if the number of observed frequencies and the expected frequency does not match.
You are asking based on the video, is it? The tutorial?
Yeah.
That I will definitely not answer. I will give you indications to it in next class because that quiz have not yet come today. I will tell this next week, but I will not give you the solution. Solution you should find out from the discourse. It is there in the discourse. You should find it out from there. Okay? That I will not give you answer to, but I will definitely give you an indication of what concept you should look for. Okay?
Okay, sir.
Fantastic. Right.
Thank you.
No problem. Yeah. Anything else?
The question paper discussion, will it be on the next side? Will it be on the next session on Saturday?
Your QP discussions will be done by the TAs, all right? So the sessions on Fridays from 5 to 7 is where they will discuss your usual QPs and the solutions to it.
Okay, sure. Fridays 5 to 7. Okay.
Fridays 5 to 7. 5 to 7 or 7 to 9. I don't remember the exact time. It's there in your calendar.
Okay,
So
sure. I'll look into it. Yeah, it is there. It is there.
7 to 9. Sorry, Friday 7 to 9.
7 to 9. I'll look into it.
Friday 7 to 9. Yeah. Those sessions is where you should go, join and find out, ask your doubts on solving. My task during the live sessions, as you would see, I will not be solving problems. I will be giving you all of these Easter eggs in different techniques. That will be my work. Okay?
Okay. Sure, sir.
All right. So any other questions?
Yeah, the session was useful, sir. Thank you.
Yeah, all right. Thank you. Okay. So I'll hang around. There are 17 people on the call. When it drops down to 7, I will stop this thing. I will also leave. Till then, I'll just stop streaming and stop recording. Yeah.
Thank you, sir. Thank you for the session.
Yeah. Thank you.
Thank you, sir.